Good morning, grade 11 students. I'm your math teacher, Wissam Sharafi. Hope all are okay. Today our lesson is also about complex numbers. Let's practice. We explained everything last week. The complex plane is referred to orthonormal system. Consider the point M of f(x) z equal x plus iy, M prime point of f(x) z prime x prime plus iy prime, such that there is a relation between z prime z and the conjugate of z. First, express x prime y prime in terms of x and y. Determine the set of points M in case z prime is real or z prime is pure imaginary. Z prime is z minus 4 into z conjugate plus 2i. You distribute z bar minus 4z bar plus 2iz minus 8i. You know that a complex number times its conjugate is x squared plus y squared. You took this property. Then you keep on, you take I common factor, you simplify, you end up with x squared plus y squared minus 2y minus 4x plus I into 2x plus 4y minus 8. This is the real, this is the imaginary. Therefore, x prime is x squared plus y squared minus 2y minus 4x, and y prime is 2x plus 4y minus 8. Part 2a, z prime is real, which means the imaginary part is 0. Y prime is 0, which means 2x plus 4y minus 8, 0. So the set of points M, in this case, is a line of equation x plus 2y minus 4 equals 0. Well, if z prime is pure imaginary, it means that x prime is 0 and y prime obviously different. Therefore, the x squared plus y squared minus 2y minus 4x is 0, which is equation of a circle center 2, 1. You divide by minus 2, and radius is radical 5. So the set of points M is a circle of center 2, 1, and radius 5. Of course, the points of intersection of this circle and the straight line D are neglected, deprived. Practice number 2. In the complex plane OUV, consider the points M1, M2, and M1 of fx 1 plus I, M2 of fx 1 plus I root 3, and Z of is Z1, Z2. Write Z in algebraic form. Find the polar coordinates of M1, M2. Deduce that of M. Deduce cosine 7 pi over 12. First, we should write Z in algebraic form. Z is Z1 times Z2. You substitute, you distribute, you take I common factor, you end up with this expression. 1 minus root 3 plus I into 1 plus root 3. This is Z. M1 is 1, 1 because Z1 is 1 plus I, which means X is 1, Y is 1. Then the radius is radical 1 squared plus 1 squared radical 2. And theta 1 is the angle. The radius is OM1, you know, it is radical 2. And cosine is adjacent over hypotenuse. The adjacent is the abscissa, which is 1 over hypotenuse radical 2. We deduce that the angle is pi over 4. So, concerning M1, it is the radius is radical 2, the angle is pi over 4 plus 2k pi. M2, because Z2 is 1 plus I root 3, M2 is 1 radical 3. The radius is radical 1 squared plus radical 3 squared, which is radical 4, which is 2. And cosine, the angle is the abscissa 1, 1 over 2. Cosine is half, then the angle is 60 degrees. So theta 2 is pi over 3 plus 2k pi. Because Z is fx of M and Z is Z1, Z2, then we deduce Z is the radius, Z1, Z2, cosine angle between them plus I sine the angle. You substitute, you end up with the polar coordinates of Z 2 root 2, 7 pi over 12. You can find the polar coordinates of Z using its abscissa and ordinate, the same procedure we followed for M1 and M2. To deduce cosine 7 pi over 12, it is abscissa of m over the radius. The abscissa of m is 1 minus root 3 x of m over 2 root 2, which is this value. So this is cosine 7 pi over 12, and also you can find sine 7 pi over 12. Practice 3, the complex plane referred to orthonormal system. Find the square root of the number, and we explained this concept before. Solve in complex set the equation we did. Let m and m prime be points of affixes z and z prime such that z prime is in relation with z, so and z is x plus iy. You can tell that. Find the real part of z prime and the imaginary part. Determine the point m when z prime is real. First, if z is x plus iy, it is the square root of this complex number. It means this complex number is z squared. Z squared equal to this, and x squared minus y squared plus 2xy expanding z squared is equal to 3 plus 4i. You equate identic method, and you end up with, if you want to follow step by step, the product is 2, y is 2 over x, and x squared minus 2 over x squared equals 3. By substitution, you end up with this equation. You let x squared is L, you find L, the negative value rejected because L is x squared, the positive value accepted, and you end up with x squared equal 4, which means x is 2 or minus 2. Find the corresponding values of I. So we end up with two complex numbers that are the square root of 3 plus 4i. One is 2 plus I, the other is minus 2 minus I. Solving the quadratic equation, it's b prime, because b is even, you can divide by 2. So you take delta as b prime minus ac, not 4ac. Or you can say it is b squared minus 4ac. It's the same. So it is 1 minus 4 minus 4i. b prime squared minus ac is, you take minus common factor, you end up with minus 1 into 3 plus 4i. Instead of minus 1, you put I squared. And instead of 3 plus 4i, you may put this value, which is 2 power 2, which is the square root of this. So we substituted for delta prime these values. You apply, z prime is minus b plus or minus radical delta prime, and z double prime minus b plus or minus. Part A, he said z prime is 1 over iz plus 1. Instead of z, you put x plus iy, and you distribute ix plus I squared y. I squared y is minus y plus 1. So you multiply by the conjugate of this. Of course, the conjugate is you change this plus into minus. You multiply up and down by the same number. You and the numerator 1 minus y minus ix. Denominator, you square the first minus square the second. And minus I squared, you know that I squared is minus 1, is plus x squared you end up with. So this is the real part, minus I into this is the imaginary part. So all you need to do is you substitute for that, you expand, you simplify, you rationalize, you multiply by the conjugate, you simplify, you try to express, or you should express, the result in the algebraic form of a complex number. So we can tell that the real part of z prime is 1 minus y over 1 minus y to power 2 plus x, and the imaginary part is x over, because this is minus I, it should be plus I, so you put the minus here, minus x over 1 minus y all to power 2 plus x squared. Part B, it is real. It means the imaginary is 0. This value is 0. So x is 0. Set of point M is the x's, v prime v, except for 0, 1, of course, because 0, 1 won't be will eliminate this value. It's not included. You need to practice. It's book volume 2, page 170. You solve number 1. Hope you understood. We'll meet again next time. Bye bye.